We've all been there, trying to remember if this particular account needs a special character, a capital letter, or if it's the one you had to reset 3 times last month. The underlying issue is how passwords are built. They rely on what's called a shared secret. Both you and the server you're logging into have to know the exact same string of characters to verify your identity. If a hacker sets up a fake login page or intercepts the data while it travels over the network, they can grab that shared secret. Once they have it, the server cannot tell the difference between the attacker and you. A global security infrastructure that depends on human beings perfectly memorizing and hiding a shared secret across dozens of platforms is mathematically guaranteed to fail. This network of glowing nodes represents the modern enterprise, where software is no longer waiting for us to click buttons. Autonomous AI agents are now actively querying databases, analyzing files, and sending emails on our behalf. But this introduces the last-mile identity problem. When these AI agents connect to back-end systems, they typically use static, shared API keys. The system at the end of the line sees the agent's key, but it has no idea who the actual human user is, or what their original intent was. A compromised agent with a valid API key can bypass normal checks, chain different enterprise tools together, and quietly extract sensitive data without raising any alarms. To safely deploy autonomous AI inside an enterprise, the shared secret authentication model must be completely eradicated and replaced. This is where the FIDO standard comes in. Fast Identity Online replaces passwords with a secure mathematical framework called asymmetric cryptography. As we see in this diagram, instead of a password, your device generates a pair of mathematically linked keys. It gives a public key to the server, which acts like an open padlock, and keeps the private key permanently buried inside the phone's hardware, guarded by a fingerprint or face scan. When you try to log in, the server sends a unique, randomized cryptographic challenge, a piece of data meant to verify that you are currently at your device. Your device uses the private key to digitally sign that challenge and return a mathematical proof to the server. The actual key never travels across the network. Phishing attempts fail because you literally have no password to hand over. Replay attacks fail because every challenge the server sends is mathematically unique to that exact moment. Digital identity is no longer tied to human memory. It is proven by physical possession of a device and mathematical certainty. This hardware-backed verification solves the agent problem by creating a delegated identity. When a user authenticates via FIDO, the system generates a secure, time-limited token that binds the human's identity to the AI agent's specific session. This allows Treecapital's Anven model to operate within a sovereign, air-gapped environment. As shown in the concentric security rings of this architecture, the agent can only proceed once it possesses that cryptographic link back to a verified human. As the agent performs tasks, it carries this combined token. Every backend database or API checks this token to ensure the agent is legitimate and that it is acting on behalf of a specific authenticated user. The system enforces strict role-based access. An AI agent is mathematically constrained to only interact with the data silos that specific person is authorized to see, preventing any privilege creep or unauthorized data siphoning. A private AI ecosystem is only as secure as the identity of the human commanding it. The most surprising result of moving to hardware-backed asymmetric authentication is that the user experience gets easier. Instead of typing complex passwords, employees access their enterprise AI with a quick biometric glance at their device. Look at the terminal window in this diagram. That 100% progress bar highlights how removing login friction accelerates system deployments, allowing companies to spin up complex architectures and achieve operational readiness almost instantly. Increasing systemic security usually means adding frustrating hurdles for the user. Here, we completely eliminate the friction. This zero-trust, frictionless architecture is what finally allows highly regulated, data-sensitive industries to confidently integrate generative AI. As the sovereignty and capability pillars in this framework show, strict regulatory adherence, like GDPR and HIPAA, allows healthcare systems to audit medical records safely, banks to automate fraud detection, and defense agencies to process intelligence. Adopting cryptographic identity is not just about solving a login annoyance. It is a necessary prerequisite to safely scaling autonomous AI into the core operations of global industry.